Welcome. So in this video, we're going to be working through question 12 here. Let's give it a read and see what we can do with it. It says, the curve for which dy dx is equal to 2x plus k, where k is a constant, is such that the tangent at 3, 6 passes through the origin. Find the gradient of this tangent and hence determine the value of k, the equation of the curve. Okay, so let's start off with A. And the question here is actually giving us a hint as to the best way to approach it. Do you notice how it says find the gradient of this tangent and hence determine? So the best thing that we can do is just do what the question tells us. Let's find the gradient of this tangent. Well, to find the gradient of the tangent, what I'm going to have to do is take the derivative. So dy dx is equal to 2x plus k. And to find the gradient of the tangent, I'm just going to let x be equal to 3. So we've done this before. To find gradient of tangent, let x be equal to 3. I'm going to end up with 2, 3 plus k, which is going to be 6 plus k. I'm going to say this is m, because m is just, the letter that we use to represent the gradient in this case. So m is going to be equal to 6 plus k. Perfect. Now it wants me to use this to find the value of k. Well, how am I going to do that? Well, what we're going to do is we're really going to stop and think for a moment what we know about this tangent. What do we know about this tangent? We know that this tangent passes through the origin. So let's picture that for a moment. Let's draw ourselves some axes here. So this would be y. This would be x. If this thing passes through the origin, it's going to look something like this, right? It doesn't have to necessarily look like that. It could be going this way, and it could, be at all sorts of angles or whatever. It doesn't really matter. But at the end of the day, it's going to look something like this. And what can we say about an equation in this form? It's going to be y. Let me do this in a better pen. It's going to be y is equal to mx, just mx. I know that the plus c is going to be equal to 0. C is going to be equal to 0, this right here, because it's going through the origin. It doesn't have a y-intercept form, a y-intercept. Remember, this is my gradient y-intercept form. So I know it's just going to be, at the end of the day, y is equal to mx. So now when I'm trying to figure out what the tangent is going to be, what I can do is I can do this. I can just say y is going to be equal to mx, and I know that m is going to be equal to 6 plus k. Whoops, 6 plus kx. So that's what it's going to be. Now to find what k is, I'm just going to sub in the point 36. Sub in 3, 6 to find k. So I'm going to put 6 in here. I'm going to go 6. Whoa, that's not 6. 6 plus k. Then into the x spot, I'll put a 3. I'm going to get this. I'm going to get 18 plus 3k. I'm going to get negative 12 is equal to 3k. I'm going to get negative 4 is equal to k. And that is going to be my answer to the first part of this question. So I'm going to come here, I'm going to come there, I'm going to grab this like that. Perfect. Now, just to be tidy, I might just move this. Let me just move it down here. And you know what? I might keep on moving it. Let me just move it down here. So it's way out of the way. All right. And it's important that you know that's how we, by considering what my graph looked like, is how we really approach this. So I got y is equal to mx plus c. I got y is equal to mx, and I got to ignore the c because I knew that it was in this form. Okay, let's keep going. B. We need to find the equation of the curve. Well, how can we do this? What I'm going to have to do this, dy dx, is I'm going to have to anti-differentiate the derivative, 2x plus k dx. Plus k dx. Now I know that k is equal to negative 4. So I'm going to come here, I'm going to replace that k with a negative 4. This is going to be 2x squared on 2 minus 4x plus c. That's what y is going to be equal to. So that means y is going to be equal to x squared minus 4x plus c, because those 2's would just cancel. To find the equation of the curve, I'm going to have to find what c is, and I can do that by just considering 3, 6. Sub in 3, 6, 2, find c. So I'm going to put 6 here, I'm going to put 3 in here, I'm going to put 3 in there, plus c. 6 is equal to 9 minus 12 plus c. 9 minus 12 is negative 3, negative 3 plus c. I'm going to plus 3 to both sides. 9 is equal to c. Therefore, I'm now going to take this, and I'm just going to write it down again. Y is equal to x squared minus 4x plus c. But I know that c is going to be equal to 9. So I can just put a 9 there. And that is going to be my final answer. Let me come here, let me grab that. That is how we do it. So just to recap there, my answers are negative 4, which is equal to k. So k is equal to negative 4, and then x squared minus 4x plus 9. That's how you approach this question. I think the most important part of this question was recognizing that our tangent was going to look like this, because it goes through the origin, and therefore we could say that we're just dealing with y equals mx, and that just made our life easier. Hopefully you enjoyed this. I'll see you in the next one.